All right, let's talk about AI, machine learning, and deep learning. You hear these terms thrown around all the time, but what do they really mean? They're not just some tech buzzwords. They're actually the building blocks of the smart stuff you use every single day, like in your phone and, well, everywhere. So let's break it down. Let's figure out what they are and how they all fit together. So, what is the real difference between them? Honestly, this image gets right to the heart of it. The best way to think about it is like one of those Russian nesting dolls. You've got artificial intelligence, that's the biggest doll, the whole field. Then you open it up, and inside you find machine learning. And then, right at the very core, the smallest, most powerful doll, that's deep learning. Okay, so to really wrap our heads around this, we're going to peel back these layers one by one. We'll start with the big picture and work our way in right down to the powerful engine that's deriving so much innovation today. First up, let's talk about artificial intelligence, or AI. This is the big overarching idea, right? The dream of creating machines that can think and reason and solve problems kind of like we do. A chatbot is a perfect example. Think about it. It's not just spitting out pre-programmed answers. It actually has to understand what you're asking, make a decision, and then give you a useful response. That's AI in action. Okay, let's go one layer deeper now. Nestled inside AI, we've got machine learning, or ML. Now here's the cool part. Instead of a programmer writing out explicit rules for every single possibility, we just feed the machine a ton of data and let it figure out the patterns for itself. Your email spam filter? That's a classic example. Nobody told it this specific email is spam. It just learned from thousands of examples what junk mail looks like, and now it sorts everything for you automatically. And that brings us to the very core. Deep learning. This is really the cutting edge, an advanced type of machine learning that uses something called a neural network, a structure that's actually inspired by our own brains. It's incredible because it can learn super complex patterns straight from raw data. This is the tech behind huge breakthroughs. We're talking self-driving cars and discovering new medicines. I mean, just think about how your phone unlocks with your face. It wasn't programmed to know your face. It learned what a face looks like, and then what your face looks like all on its own. So this image really shows you what the deep in deep learning is all about. You see those layers in the middle? Those are the hidden layers, and that's pretty much where all the magic happens. Data flows in, and the first layer might learn to spot simple things, like lines and edges. The next layer takes that and learns to see shapes, like eyes and noses. And the layer after that puts it all together to recognize a whole face. It's like it's building up its understanding, piece by piece, layer by layer. So if you're wondering what the real game changer is between regular machine learning and deep learning, just look at this table. See that row for feature extraction? With traditional ML, a human expert has to go in and tell the machine what to look for. Hey, pay attention to these specific features. But with deep learning, it figures out the important features all by itself. And that one difference is everything. It's why a deep learning model can look at a medical scan and spot a tiny tumor that even a trained doctor might miss. It finds the patterns we don't even know to look for. All right, so we've got a handle on what these things are, but the next big question is, how do they actually learn? Well, it turns out there are two main ways we can teach them. Two different teaching styles, you could say, and it really all comes down to the kind of data you feed them. So, on one side, we have what's called supervised learning. This is basically like giving the machine a study guide with all the answers in the back. You give it a bunch of data that's already labeled with the correct outcome. Then you have the flip side, unsupervised learning. This is more like dropping the machine in a library and telling it, figure it out. The data has no labels, no answers. The machine's job is to just dive in and find interesting patterns and structures all on its own. And this chart here really breaks down that difference. Just look at the main goal for each. With supervised learning, your goal is almost always to predict something. Is this email spam or not? Will this customer buy this product? But with unsupervised learning, the goal is to discover something, to find hidden groups, like figuring out different types of customers you have based on their behavior. And, picking the right approach here is one of the most crucial decisions you make right at the start. Okay, but building a really good model is more than just picking a learning style. It's like a delicate balancing act. You're constantly trying to manage these two competing forces that really decide how good your model is. And those two forces are called bias and variance. Let's start with bias. The easiest way to think about bias is that it's all about accuracy. It's the gap between what your model predicts and what the actual right answer is. So low bias, that's what you want. It means your model's predictions are right on target. High bias, on the other hand, means your model is just consistently missing the mark. And then you have variance. If bias is about accuracy, variance is all about consistency. Imagine you train your model a few different times on slightly different data. Do the predictions stay pretty much the same, or are they all over the place? Low variance is good. That means your model is stable and reliable. High variance, that means your model is super sensitive, and its predictions are scattered and inconsistent. This image of the targets is the perfect way to understand this. Just look at the top left. Low bias, low variance. All the shots are clustered right in the bullseye. That's the dream, accurate and consistent. Now look at the bottom right. High bias, high variance. The shots are way off target and they're scattered everywhere. A total mess. Our goal every single time is to get our model into that top left box. But trust me, that is the core challenge of this whole field. So what happens when you don't get that balance right? Well, you run into two very common classic problems. It's either a model that's just too simple, it didn't study enough, and completely misses the point, or you get a model that's way too complex. It basically memorized the textbook, including all the typos. Here we see them in action. On the left, you've got underfitting. See how that line is just too simple? It's trying to capture a nice curve with a straight line. It's just not going to work. It misses the real pattern entirely. That's a classic high bias problem. Then on the right, you have overfitting. This model is so complex, it wiggles and squirms to hit every single data point perfectly. It's basically memorized the data, including all the random noise. Now, it might look great on this data, but the second you show it something new, it's going to fall apart. That's a high variance problem. So how do we fix this? How do we find that perfect Goldilocks zone in the middle? Well, the answer is a collection of techniques called regularization. The best way to think of it is like having a complexity dial on your model. You can use these techniques to turn that dial down a little bit to stop the model from getting too obsessed with the noise and force it to focus on the bigger, more important pattern. This is how we prevent that overfitting and build a model that actually works well on new, unseen data. So there you have it. We've gone from the big picture of AI all the way down to the nitty-gritty of balancing bias and variance. These really are the fundamental building blocks of the tech that is changing, well, everything. So now that you know how it works, it leaves just one final question for you. If you could train a machine to solve any problem in the world, what would it be?